How's everybody doing? Excellent. So we had a small group, which is fine. I won't make you move. I won't do that to you. But we have a little chance to make a more intimate talk. So feel free to ask questions. Just a little show of hands. How many of you are kind of security practitioners? And how many of you are developers or work with developers today? Okay, awesome. And how many of your organizations are using and embracing DevOps or DevSecOps already? A couple? Okay, fantastic. And how's that going? Slow?
Slow to implement.
Okay, slow to implement. What are some of the challenges?
Just getting everybody on board with it.
Okay.
On the same page.
On the same page, okay. What else?
For us security folks,
What's that?
it's been a nightmare for security.
A nightmare for security folks? Okay, well, I hope I can help with that. That's definitely the goal of this talk, is to help with that and to make that transition better for the security folks. I think also for those of you that work with developers, some of the things may help you relate a bit better and understand some framing around it. So as this talk is about evolution and evolving a mindset, I wanted to start out with what my evolution was and around some of these areas as well. So my evolution really started at a very young age. I started programming at 10, and so my driver at that point, I just thought I was the shit because I made a little sprite move, with some lines on a on a little computer at that time, on a little TI computer that made a little sprite move, and then the next summer I had a little rocket ship of color that had my name in it, and it went across the screen, and that was the starting point of the process for me, and through that I grew my development skills in high school, and then began as a software developer, and then transitioned into InfoSec. My first kind of project in that area was to do software that did data mining, and this is back in 2002, before big data and data mining were like hot things. We were doing clustering and other data mining kinds of algorithms to identify anomalies in network traffic. And so that was my foray and my first experience as InfoSec as a profession, and I loved it and kind of transitioned into InfoSec, into red teaming and pen testing. But as part of that evolution, what I recognized was that coming into those assessments, the easy targets for me to go after was the software, because I could identify vulnerabilities in the code. Most of the people I was working with at the time were from network or operations, and they really had no idea. So they were focused on the lower level, layers of attacking things, and I was able to come in and start attacking higher order, functionality in the systems that we were taking down. And so that was fantastic and a lot of fun for me. But a part of that evolution, we started to realize, so much of the vulnerability is moving up the stack, right? It's changing to the software, and so I was able to capitalize on that, but also then create new opportunities. And then my next evolution went from being a security professional and assessing systems to helping and teaching developers how to fix them, right? And so actually coming back around full circle to software development, but in focusing and helping them build security in and improve the security of those applications and to adopt better design patterns. And then in the last few years, more recently, it's been focused on how to do this at scale, right? How to actually align those security practices and the things that we want to get done from a risk management perspective, but to integrate that into an Agile, a DevOps model where you're releasing constantly, right? And how do you do that in a different process world? And so that's where I came to this talk, and I wanted to walk you guys through some of that perspective, and the evolution of these things matter, right? So the evolution of computing is I think really important to understand in this time frame that we're in today, in that when operations started out, that was like operating the mechanical computer, right? So the women in the upper left corner there are like cleaning and maintaining vacuum tubes, right? That's what operations meant at that time of computing. Was it like you had to physically maintain all the computer equipment to keep it running, right? And if we go back, centuries ago when people had abacuses, right, it was to make sure that you had enough tokens in your abacus to do the math, right? And that was the extent of operations that you had, and you didn't lose your tokens, and you could do that. As we evolved, we went from vacuum tubes to more digital computers, and you had punch cards. And so, punch card operators, that was their job, was to load and stack and keep from crumpling punch cards that were getting loaded into the machine. And many of the first programmers didn't program in code. They had to understand the punch card and have a system for how to organize and write code, write the commands into their punch cards. And we've evolved from that over time into the mainframe, and then the desktop computing world came through, right? Windows, DOS, the Mac and Apple, Linux. And so all of this changed, and you had operations now happening there, and then you had the shift to client server. So rather than these large hunking, systems in hyper-cooled rooms, you had client server, and you can do that architecture anywhere. And operations shifted to now how to manage networks of computers, right? And so you had people worried about token ring and like how to best do that. And that's evolved now, like who today deploys token ring, right? Nobody even thinks about that today anymore. And so the challenge is, what's going to continue that evolution? And if you asked, when I graduated high school, data centers were the thing, and when I came out of college, but relatively early in my career, in the mid-2000s, right, VMware came around. And this idea that you could have multiple systems, multiple workloads running on a computer, and that was revolutionary. And then the next evolution on that is cloud and having web services, and even that itself has evolved from the early launch days of AWS. Really, you're just renting a computer in the cloud, and it was just that compute capability. But now it's changed, and you're getting not just compute capability, but you get databases as a platform as a service. You get all of these different capabilities. You have SDN, VPCs, Dynamo. I mean, every single service you can think of now is getting productized in the cloud, not to mention all of the SaaS services you can connect to that are API based and that happen. And so the notion of what your operations are to run your enterprise has completely shifted. And today, modern enterprise, your operations people are not just thinking about the physical servers, but they're thinking about VMs, but then they're also thinking like, well, our email's not working. Well, we don't host our email. It's in O365, right? Or it's in Gmail. And so your operations people still have to support the business, because if the CEO's email doesn't work, like somebody's going to fix it. And it's going to be that operations person, but they have to now know and to connect the dots to all these other services. So there's a lot of complexity and change, but also a shift of skill sets and a shift of model of how to think about your role and to think about all the systems and components that are a part of it. In the same spirit, we've evolved in the programming side too, right? As I mentioned earlier, programming initially was, understanding the binary, punch cards, and then you were lucky, then you can get to assembly, right? And so people were able to write in assembly, which was fantastic compared to punch cards. And then you had the first programming languages that came around that allowed you to have a more human readable form, right? So A and B, which didn't cause as much traction, but C, when C came around, that really hit the nail on the head in terms of growth and driving that. Pascal, Fortran, all these other languages that have been around. And we have a ton of evolution in that, but we also have new evolution now, right? Nobody really, would have thought almost all these languages, so many of the older ones came from, Bell Labs, right? A, B, C, Ada, all came from Bell Labs, these big research institutions and DARPA, and funded by government research and funded by the research entities. We've now had, Facebook Google, Apple invent brand new languages, right? Swift, Go, right? I mean, all of these different frameworks that have come together, right? Even, React and React.js, like you have React-based apps, right? And yes, it's still JavaScript related, but it's actually a slightly different language. And you've got all of that. You've got Node.js. So all of these different evolutions of programming technology are driving this. And I would describe that, someone who was a developer 10, 20 years ago, today, like the fundamental logical processes of developing software are the same, but all of the tools are completely different, right? The language itself that they use is completely different. And that's going to continue to evolve. The other facet that's changed about this was we've always thought of like code doing logic. But the complexity of operations is now code doing network, right? That's what SDN is all about. And code doing configuration of your server. Right? Code dynamically deploying and scaling your service. Right? What does that mean? Auto-scaling is, it's a great concept, and it makes, when you step back far enough, you're like, oh great, I can just get, more compute capability if my traffic spikes on this app. What that means is you have code that's figuring out logically, am I at a right load level to support the traffic? And if not, spin up new computers. Right? So code is performing that operations function, which used to be a real person having to add new computers to a data center, now just automatically spins that up. And so there's this merger that's happening between the two. The other aspect of this, and that's important, is the process evolution that's occurred. And that process evolution has happened both in software development and in operations. Although they don't always know it, and they often will fight it as well, and that happens. So I think we all know the waterfall model, and I'm sure people curse it, but there's still lots and lots of enterprises and applications that are still waterfall. Even if they say they're agile, they're actually waterfall. Right? If your product manager says, when will I have this feature, and if it's anything longer than a week or 2 weeks, you're in waterfall, right? That's not what agile is meant to be, right? You evolve and you have a shorter deliverable. So you always have this challenge. But what's happened over time is we've evolved the thinking about processes and how that works. And so you have Brooks, and but also in a great, fantastic book, if you haven't read it, is The Goal by Goldratt, which was also the basis, kind of a model for the Phoenix Project. And I would hope if anybody is at this conference that hasn't read the Phoenix Project, like that's number 1 on your reading list. I'd make number 2 on your reading list, The Goal. And Mythical Man Month is fantastic to understand that as well for software engineering. But what's happened is we've had this evolution in process and thinking. And so you have the Boyd loop, also known as the OODA loop, that came out of military research and thinking. And the plan, do, check, act loop, which is very much what Agile is all about. And this model, very simplistic Kanban board. But all of these things have come around the idea of controlling your process, being able to speed up the ability to respond to business needs. And that's really what the goal, constraint theory, operations research is all about, right? How do you more quickly adapt to that? And that's, I think, really well illustrated in the Phoenix Project. Is one of the key drivers for why DevOps is winning and why DevOps can help businesses succeed. And so kind of the coalition, or sort of the collision of all of these things, right? This evolution that's happened in operations and computing, in programming languages, in the process of developing software and technology. We've come to this place of DevOps, and we have this cycle, right, of planning, creating, verifying, packaging, releasing, configuring, monitoring, where we're trying to do all of these things in an automated, hyper-fast manner, right? I would say from at least the evolution that I'm kind of espousing and talking about or setting up here is that I think this model of DevOps is inexorably tied to the evolution of SaaS, right? It's software as a service. And so, when you're SaaS, you're more capable of doing this, right? But the principles still apply to shrink wrap software. The difference is what your deployment, right? What release looks like, what configure and monitor looks like changes, right? So sort of like this half of the equation changes a little bit because you, as the same team, you don't have that ownership. But I would think from that perspective, in my opinion at least, that changes from being DevOps, because if you look at, these are the traditional dev roles, these are the traditional ops roles. If you're taking this half away, because it's your customer that's deploying it, right, and you have the development, then you've actually separated the two. And so that doesn't mean the principles of connecting the dots can't help, but it changes the equation a bit. And what that actually means is, to me, the challenge is for you as an enterprise software developer or shrink wrap software developer, find ways to make your development and your product creation more integrable to your customers' operations and actually have better communication channel between the two. Yeah. Right. The other evolution I've seen in that space is the shift to managed on-prem, right? And so a lot of, and especially in the big data world, there's a lot of this where the SaaS platform is actually, what's happening. That's where all the DevOps is happening. But the on-premise customer that doesn't want their data in the cloud, that wants the data on-prem, the SaaS platform is actually deploying into their on-prem, which is still, it's like the customer-owned AWS or customer-owned cloud account. And so it's actually, it's an orchestration management layer. We can talk about that in a bit. So we have this evolution, and that's really critical. So kind of putting all this together, I wanted to talk about an example. And this example to me is what, for me in my evolution, when cloud first came around, I was like, this doesn't really make sense. Like, it's just a lot of buzzwords. But then at one point I heard this mental model, and it was like, oh wow, this is going to change the world. And so I wanted to share this with you, right? This is what we think of as a data center, right? Computing, and you have nodes, and you might have, even with virtualization, you have multiple things working on this realm. But imagine for a second, that you're running a service, high volume service that's available to, half the world, and you run it on, on multiple systems. And so the model that came to me, I was working with a company at the time. I was talking to a company about a job, and they're like, a small deployment for us is 100 nodes, right? So imagine that your service, right, the smallest size service that you have in your enterprise is 100 nodes, and you redeploy that service, 15 to 20 times a day, right? And so the way they do that is they don't deploy 100 nodes, right? The way they do that is they have 100 nodes that are running the current production service, and then they spin up a new 100 nodes with their next build, and then start to funnel traffic from one to the other, right? And so they'll take traffic from one node on the old version and move it to the new version. See how it's doing, and then 5, and then 10, and then 100, right? And then until everything's done, and all of this is running, working correctly, serving traffic in the right way, and then spin these down, and then do it again the next time, and the next time, and the next time. And so, what is that? That's a completely different mental model of what computing is, right? You've taken that compute node, right, the server that you're thinking of, and that lifetime of that server might be, an hour. It might be 15 minutes. It could be a week, right, depending on how long between code changes. But it's not a year or 2 years or 3 years, which is your typical traditional data center lifecycle, right? Like HP sells you a server, they have a lifespan of 2-3 years they give you, right? Like they expect that to be running for a long time. That's not the model. that's really successful. But it's also at that scale, right? And that's what it took for me to really realize that the power and value is at that scale. Imagine the things that you can do, right? With that, from a deployment perspective, feature testing, things like A/B testing, to be able to say, oh well, this version of a login page versus this version of a login page, how many users do we get, or this particular feature, or the ability to test out a new interface to a small percentage of your users, right? Like these are things that are really complicated in a traditional computing sense, but in this model, it's fantastically easy. And that's the power of cloud plus DevOps kind of put all together and having all these teams work together. Okay, so we haven't talked yet at all about security. So let's start with that evolution. And security as a industry, what we think of as modern security is relatively recent, but security goes back, depending on how far back in time you want to go, to castles and moats and lots of other defenses that you've had for things. Even things that we think of as like encryption goes back to, before, to the BC era, to the Caesar cipher or the ROT13 cipher, as we think of it now. And we have that both in mechanical forms, all throughout the Middle Ages. Different leaders and kings would speak in code and have coded books to communicate back and forth across the world. And so, the aspects of security that we think about, confidentiality, integrity, availability, like these have been around as concepts for a while. They're not exclusive to the modern era. But more recently, we have an evolution into digital security, and so forth. And so one of the, I think, is a great example, 30 years ago, a firewall was a fantastic invention. Everybody needed to have one. They were amazing technology. They were super expensive, but you had to have it if you were going to be on the internet, right? You had to put in a firewall. You had to have a DMZ. Who today would recommend, if you had a child, a teenager, who today would recommend that child get a CCNP and become a firewall expert? Right? Nobody. But think about that pathway. Like in the span of 30 years, maybe less, right? We created an entire field of people, right? New technology, this firewall that came around, then it got expensive. We had to create all this education and support infrastructure, CCNP programs, all these certification programs, and so all this professional education. And now you've got a bunch of CCNPs without a job, right? Because it's been evolved to unnecessary. And if you're doing cloud today or moving in that direction in any sort of way, it's baked in. Right? And even, I get a firewall on this. It's free. Right? It comes with the OS. Every computer has one. And so it's a trivial evolution in terms of technology that, it's shifted from that physical firewall appliance, which is all that they were originally, to now it's just code on a computer. And that evolution is happening more and more with more and more facets of what we're doing. And of course we're here, it's an OOPS conference, and this evolution is going to continue. And so part of what I hope to impart is that it's time for us as security people to evolve to this new phase of technology and these models. And so let's go back to this for a second and imagine that cloud model that I talked about before, right? Where let's say our small deployment is 100 nodes, and the way we redeploy our service is spin up a new 100 nodes and spin them down, right? And that's how we operate this service. How do we apply our traditional security practices to this compute model? And I'll start with a very simple example. Let's just look at kind of two things: patch management and vulnerability scan. Right? How would we think about vulnerability scanning and patch management in that model? Right? If you've got 100 computers, 100 nodes for this web application or web service at a time, and then you redeploy that on a regular basis. Well, are you going to buy, Nessus or one of the other Qualys or another tool? And nothing. All those tools are great. I'm not saying anything bad about them, but what does that mean, right? To scan those with those great technologies. Well, most of those systems, those scanners, are based on an asset model, right? Where you create assets, and so you find all the IPs in your network that have computers, and you scan them, and then you have a report for each asset. Well, if I spin up 100 nodes and I spin down 100 nodes, and all those IPs are dynamic, right? And I do that, even if it's once a day, but let's say it's 4 or 5 times a day, I've now got hundreds of IPs for the same functional service that I now have to track in my vulnerability management system, right? And then keeping up with that. Likewise with patches, right? And the patch and versions of the OS, and even just OS level patches. We won't get to software patches yet. And so trying to track and manage all of that, at this point we're just curving bullets, right? Like, how are you possibly going to track and manage all of those things and creating lists? And so trying to do that by hand or with the tools that we have, available in this assessment-centric model, it's pretty crazy, right? And who could do all of that in their head, right? If you could hire someone that could manage that in their head and manage the vulnerabilities of all that, I mean, you're just unicorn hunting at that point, right? Like, so this is kind of a crazy model. But let's go back to this in a second and rethink what we think about vulnerability management and patch management in this model. So in this model, right, well, what is the lifetime of a vulnerable node? If I redeploy the service, let's just say 5 times a day, right? How many hours is a vulnerable node available? Right? Only a couple hours at a time. If I can patch the next deployment, right? Or if I can fix the vulnerability that my scanner found in the next deployment. Now, if it's the same vulnerable code that gets redeployed, well, now the persistence is there, and all that happened was it changed the IPs. So we've got a different challenge in terms of what that is, but there's also a great opportunity to think about things differently, right? Because if my ability is to identify something that's wrong, I can take action in a different way, right? So let's say in that manner, let's say one of these 100 nodes that spin up starts acting weird, and we find out that there's some malware that got onto it, or somebody did a command injection and ran an action on it. Well, all I need to do is just kill the one node, and it's gone, and I can spin up another one in seconds. So that ability to react and respond is so much more powerful in this model, right? If I have to patch a system, I can run a patch on this operating platform the same way that my developers do their deployment functionally. Is I patch the node, right? I deploy the 100, right? I flip over one, make sure that it doesn't affect the functional service, and then bam, splat, run through the rest, and now we're patched. You could create a model in this way where even when the developers are pushing new code, you're also patching. Right? Because now they're used to this instability. The number one reason that teams and developers and operations people say, no, we can't patch, is I need a patch window, I need stability. Right? I don't want your patch to fuck up my service for my customers. Right? Well, if we as a security industry embrace the model, we don't have that problem anymore. Because we can deploy the patch the same way that they would deploy a feature change. And we can ensure that because we did that, that patch goes through the same test cycle and the same deploy cycle and the same A/B test that their feature did, and bam, it's rolled out to everybody. But what that takes for us as a security industry is to switch our model of what patching is, right? To switch away from like patch Windows or patch Tuesday, right? To patch in your build cycle, right? to patch in line in your CI/CD pipeline, to make a patch a pull request. And that's a completely different way to think about things. But I think we as a security industry and as security leaders have to embrace that model, because that's the best way not only to reach the DevOps folks, but it's actually more powerful for us and what our goals are. And so in doing that, I think as an industry, we have an obligation and an opportunity more than anything else to switch from a model of assessment and remediation to a model of integrated actionability, right? To find ways that we can integrate security into a pipeline, into a process that creates direct action that's automated and scalable as much as feature development or operations are in a cloud model. And I'll kind of give you the example of that. So how many of you, if I ran, let's say I have a website and I ran our standard suite of OWASP tools and web application security tools against that, what's the average of vulnerabilities I'm going to find in that website? 5 or 6. Just 5 or 6?
Well, you're going to get a pile.
I'm going to get a pile.
Real ones.
Okay, exactly. So, how big is the pile, though? Let's start with that. How big is the pile? 100, 300? Pretty big, right? 100, a couple hundred, right? Maybe 1,000, right? On a good day, on a complex enough website, yeah. Exactly. Yeah, absolutely. And so if we get the hundreds of pages, right, and I get this report and I go to my development team and I'm like, here, right, you got to fix all this shit, right? What does that turn into, right? And then what's that model, right? So the model is, I say, here's all the problems with your app, go fix them, right? See ya, peace out. And they have to deal with this, right? And then we come back and a month later, a couple weeks later, we're like, where's those TPS reports? How's that vulnerability? Did you burn all these down? Right? That's what we've become as an industry with the assessment and remediation model. Right? That's what we are as an industry, as an assessment and remediation model. And I think it's time for us to change that by changing us. Right? It's not their fault. Right? Because if you did that to somebody, right, you drop that on someone that you work with, right? Just imagine what that feels like, right? You're there, you're doing your job, somebody comes in and says, you got to do all of this, right? But your feature is successful, your service is successful, your users are happy. Of course you're going to be defensive. So we have to embrace DevOps to do that. And that's the real key to doing it. So going back to this, how do we do that? How do we integrate security into this cycle in a way that scales, in a way that makes sense? And I think the basic starting point is to build security into the model, right? And what are the steps? What are things that we can do at each phase of that process? And whether you're agile or iterative, even if you're waterfall-y, if you're doing or embracing DevOps in some way, you're going to have these actions in these phases. And so, we can do that, right? So planning, in most agile processes, that planning happens during, a backlog grooming cycle, right? Or product management meeting, right? Where they say, okay, here's what we want to do and here's what we accomplish. And that requires you, in order to be at the table, to have that, you have to have a relationship with product owners. Right? You have to have a relationship when they're thinking through their business priorities. And you actually have to have the ability to align to the business priorities to be into that plan in order to build that in. When they're creating, right, when they're building, defining, that means you need to have security integrated there, right? Secure coding is one way, but that also means like having a relationship with your development teams, being integrated and involved with them. When they verify their builds and actually do tests and bake in, that means you need to have security unit testing. Right? How many people run a security test that fails a build? Right? This is our problem. But if you're a developer, what do you deal with every day? Failed build, right? Because that's the process of software development. You write code, it mostly works, but this one test fails. Fuck it, I want to fix this test, right? And that's what you got to do in order to have your pull request approved and to merge your code and to actually deploy. It's got to pass all the tests. So if we can build in the security tests at that stage, now we've presented the developer with a model that works for them, right? Because they know that's their job. They know their job is to write features that meet the functionality, and then to work those features all the way through the testing, integration, baking, hardening if they do hardening, and then release through the CI/CD pipeline and get it and ship it, right? And that's their endpoint. So if you can be in that cycle, that's fantastic. Likewise, in packaging and build, and this is where it still applies even to the enterprise kind of shrink wrap software model, is you can still build security into that interface, right? And you can build it into that design. If you're doing SaaS, then that packaging and build and release and deploy is straight out to the cloud, right? And straight out to your deployment. But that means you need to have security built in to that, right? So the packaging and building into your service, if you're Dockerizing or in Kubernetes, build security into those frameworks. Right? If you're using Docker, it's a great way because what you can do in Docker is on build, you can run things. And so one of the things that we try to do is on build, when they build a new Docker image, we do an update. We do a software update right there and say, okay, you must be up to date. And it's going to do that every single time you build your Docker image, which means that even in dev, they're patching every day. Right? Every time they rebuild and redeploy the service, it's getting patched. And so we can do that. And then on deploy, right, once you actually have the service and deployed and running, that's a fantastic place to do your AppSec testing. Right? So as soon as the service is deployed, even in intag or development, run your web scanner on it. Right? And yes, the web scanners technology-wise aren't up to date where you can do a deploy, have it fail, and then have it fail the build. Right? The scanners take a little time. But what you can have it do is fail the next build, right, if it hits the right trigger. And so you still get that in line. You get yourself some time to do that. Have your configuration be secure by default. So as they configure that service, as it deploys out to their CI/CD pipeline, all the default settings in your pipeline are secure by default. Right? And then tie in the security things to your metrics. Right? Every single SaaS app or even on-prem app, you've got tons of developer metrics and logs. Right? They're capturing all of that. The challenge for us as a security group and security team is to get our security metrics into those monitors, right? As opposed to the security dashboard. Right? What we're used to is like, oh, we don't want to, a CISO is like, I want a single pane of glass to tell me security of all my systems. No, I'm sorry. Right? Get it into the development systems. Make them the monitors because they're the ones that are going to be responsible if that service is down. They're the ones who are going to be paged to fix their service. So it's not the security team that can come in, right? You don't have the knowledge and skill set of how their service works to be fast enough to respond to an alert. You just don't. You're never going to scale if you have more than 2 or 3 applications. You're never going to scale the security team to be able to respond in a meaningful way to any kind of live event in one of those apps. You have to have the DevOps teams be empowered to do it, which means you need to get them the right security metrics, the right alerts, and then follow their incident management and paging process for how you do it. And that's what I think of as kind of DevOps-centric security or DevSecOps. Right? I talked about a bunch of these already, so I won't go through all of it. But a key thing on all of those is, make the action clear. Right? If something happens in your security unit testing that's critical, in static analysis, and the security testing you haven't deployed, fail the deploy, fail the build. Right? Create those immediately actionable findings. And if we do that, that's where we can scale. Now, in order to do that, in order for someone to come along and say, I'm going to block your build process and block your deploy process, you have to do something else first, which is you have to have trust. Right? They're never going to let you do that unless they trust you. Your development teams, the DevOps teams, if they don't trust you, they won't let you fail their builds. They will hit you with a brick wall at that point. No, you're not going to touch our builds. So the only way to do that is to create trust. And that means listening to them, understanding their problems, understanding their constraints, their feature roadmaps, their business requirements, their goals, but also scaling back on the FUD. Right? We as an industry, as security people, we are great at FUD. Right? We can FUD ourselves. Right? I mean, you can see that at every single conference. Right? We can FUD ourselves in terms of getting worked up over some very small risk. But that doesn't mean that those aren't important. We just have to understand the context, right, and scale it. Demonstrate competence in DevOps, right, or in software development in some way, right, or show that you understand their architecture. And participate in blame-free retrospectives and root cause. I mean, this is, I think, so huge in terms of building that trust. Right? When an incident happens, whether it's a security incident or even a regular outage, be part of that retrospective. Right? Help them understand that you're not blaming them for what happens with their service. You're part of their team. Right? You want that service to succeed as much as they do. Because the alternative, if we don't do these things, if we don't establish that trust, and you decide you're going to fail builds on every time the web scanner fires, right? So you get those hundreds of vulnerabilities in your web scanner. You'd say, oh no, you had a vulnerability in the web scanner. We're just going to fail your build, right? Then you're throwing them off a bus, right? Then you're the asshole. So we have to build trust first before we do that. And the way we do that, and the way you build trust is to be part of a team, to do things together, right? So find something in that realm that makes that possible. And the way that I think we can do that as a security industry, and this is where it's the hardest, is we also have to think atomically. Like we're used to that assessment remediation model. So we're used to looking at an app and saying, oh, here's all the problems. Right? We're great at making those lists of big problems. What we're not good at is thinking atomically. And this is what DevOps and that model has created, is the ability to think atomically and focus on one thing at a time. And so if we can do that and focus on one area, but do it fast, scalably, and quickly, then we have the ability to go to the next one, and the next one, and the next one. Right? You do one atom at a time, but you get better and better and faster and faster. And that's what Agile is all about. That's what DevOps is all about. And there's ways that we can do that. I'll give you an example, right? So static analysis is totally, this stack of paper. And I don't say that in a pejorative way. I worked at Fortify for 5 years. The technology is amazing, but man, it can put out a ton of vulnerabilities in just about any piece of code that you want. And so the challenge is, how do we get away from that model? Because what we want to do is we want to fail the build, but we don't want to be the boy who cries wolf, right? We don't want to do it unnecessarily. And we want to build trust. And so a way that we can do that is by focusing on that atomic incremental improvement. So rather than worrying about all of the things that a static analysis tool can find, focus on 1 to 5 issues per Agile sprint. Right? And really narrow the focus. And it's hard for security people because wait a minute, you're telling me they only have to fix this and I don't have to, and I'm telling them they can ship with all this other vulnerabilities? Oh my God. No, right? The reason you do this is because this allows you to get faster. Because if I go to a development team and I say, man, there's these 300 things that you have to fix before you can ship, what are they going to say? They'll be like, no, we don't have time. See ya. But if I go to them and say, hey, look, can you guys squeeze in these 1 to 5 things? Right? And if one of them is really complicated, maybe it's only 1. But if they're pretty easy, could you do these 5 in this sprint? And most of the time they're going to be like, yeah, we can knock those out. That makes sense. And then they include it. And you do it again the next time, and the next time, and the next time. And so in 3 or 4 sprints, you've fixed 25 or 30 issues in a rapid manner, whereas if you had gone to them with the full list up front, what's the likelihood you would have gotten any more than 5 as a commitment in the next 3 to 5 sprints? And it's not about the technology, it's about how we think about the problem and how we communicate it and how we connect and build that trust to them. The other way to kind of frame this is also to have a dialogue with them of like, what are the critical categories, right? And the only way you can have a discussion about the critical categories in a meaningful way is to understand their business needs, what are their business goals, what are their operational goals for that service, and align to those. And in doing so, that's how you can start to build trust. The other thing you want to do is allow for variance in team maturity. If you work with multiple development teams, some development teams, they're like, oh yeah, we'll take 50 issues, we'll burn them all down, we'll just do a hardening sprint, and we'll do it all for you right now. Because as a team, their maturity is such that they are willing to do that. Another team may only be capable of doing 1 or 2 at a time. And so you can't treat them all the same, you have to kind of allow your relationship to vary based on their maturity level. So in doing this, what we're trying to do is to reduce that work in progress, right? That stack of vulnerabilities is work in progress. And if you haven't read The Goal, if you haven't read the Phoenix Project, read it. It'll break down all of these things. But the idea is to find the constraints and find ways around the constraints, right? Take constraints out of your pipeline. Right? Take constraints out of your relationship with developers. And that's what's going to allow you to move fast and to scale easier and faster and to secure easier and faster. Because if you don't, that's where we're just trying to do, I couldn't get more than a short clip of this, but where Lucy's just keeping and trying to keep up. Otherwise, we're just going to be trying to keep up and we'll never do it. So there's tons of opportunities in DevOps and in DevSecOps for all of us, right? And to bring that away. There's that ability to be secure by default, right? To automate asset management, software-defined security. Other things that you can do is tag, right? Every single cloud service, especially if you're in cloud, has the ability to do tags. So tag your service with what the needs are, right? When earlier today, I think Shannon was talking about data mapping, and I think Wendy Nather as well. We're both talking about data mapping and like understanding where data goes in your enterprise. The best way to do that in a scalable way is using tags. And you can do that in code in CI/CD pipelines. Have transparency with your development teams, and especially in how you want to integrate in these cycles. And then, do the principles, right? Publish, test, observe, adjust, iterate, change, and keep changing, keep evolving what you're doing. Because if you're evolving faster, they're going to see that and they're going to respect that because they know they have to evolve faster. And that's going to help you build that trust. So there's a few things I hope you can take away from this. Is a model that helps you approach DevSecOps, build trust with your DevOps teammates. Think atomically, operate at scale, and automate. And then, one of the ways that I try to do that is I think of that compute model of like, if a minimum deployment is 100 nodes, right? And I want to redeploy that 5-10 times a day, right? How do I secure it? Right? How do I rethink all of my security processes around that deployment model? And how do I integrate into those pipelines? And I think overall, DevSecOps shouldn't be scary. I mean, it should be scary in the fact that it's change, but it's also a wealth of opportunity. And I think, that's been well covered by other speakers as well. So I'll leave it at that. If there's any questions, feel free to come up and chat with me. And I hope you found something interesting and novel here.